Okay, simplifying radicals is pretty easy. So think about if you had the square root of 4 is 2, square root of 9 is 3, so forth. So finding the square root of something is not difficult until the number under the radicand is not perfect. 4 is perfect, 9 is perfect, but the goal is try to come up with factors of 20 that might have a perfect square. So if you do factors of 20, 20 and 1, or we're already at 20, 10 and 2, 5 and 4. 4 is a perfect square. So if we say 4 times 5, you can ask yourself, what's the square root of 4? Cancel out the 4 and put a 2 on the outside. So 2 root 5 means the exact same thing as square root, oops, sorry about that. That was confusing. As square root 20. Square root 20 is the same thing as 2 root 5. All right, now I'm going to cover that up. Now I'm going to show you a different one. Now look at what we have. We have the square root of something that has a variable in it. So we have the square root of 8n cubed. Again, if you think about it, factors of 8, well, this one's even easier because it's 8 and 1, but 4 and 2. So I'm going to break 8 down to 4 times 2. And n cubed is, if we do a factor tree of n cubed, look what we've got. We have n times n squared, and then n squared is n to the first times n to the first. But we don't even have to go that far, because n times n squared, if we put that in here, well, the square root of 4 is 2. The square root of n squared, these two things undo themselves, and n comes out, and look at what we have left under the radical, 2n. All right, so as you try these out, make sure to break down the numbers or variables underneath into things with perfect squares. All right, that's it.